Good morning. Today we're going to learn how to graph quadratic functions or parabolas given the equation in either vertex form, transformational form, or in general or standard form. Okay, so the first thing I want to emphasize is how a quadratic or a parabola actually looks from its parent function. So right now we're graphing this top y equals, because remember f of x is just y, f of x equals x squared. Now, what I want you to notice is the very minimum this can be is 0. 0 squared is 0. If I plug in a 1 or a negative 1 and I square it, I get a positive 1. So what I'm trying to emphasize is if I move 1 to the right of the vertex or 1 to the left of the vertex, I go up 1 squared, which is 1. If I move over 2 to the right or 2 to the left, right, I'm going to go up not 2, but 2 squared, which is 4. Again, if I go over negative 2, I go up 2 squared, which is 4. If I go over 3 to the right, or I go over 3 to the left, I go up not 3, not 6, but 3 squared, which is all the way up here to 9. If I went over 4 to the left or 4 to the right, I'd go all the way up to 16, which is off the graph. That's true regardless of the position of the vertex, as long as there's no a stretch to it. There's no number in front, and I'm going to show you what happens when that happens. So in other words, let's first show you that if I graph this one, it's going to shift it 5 units to the right. That's 5 units over here, and it's going to shift it 2 units up. So actually, let's get rid of this for a moment. Now let's go, so I'm going to graph that one. Now if you'll notice, that's a horizontal shift. And since it's minus 5, it shifts it 5 to the right, and it shifts it 2 up. That's the plus 2. But now, from the vertex, think if I move over 1, look, it goes up 1, or 1 squared. If I move over 2, it goes up 4, which is 2 squared. Whether it's left or right, if I go over a negative 2, I go up 4. If I move over 3, either left or right, I'm saying that backwards, left or right, then I go up 9. 2, 4, 6, 8, 9. I go up 9 because there's no stretch to it. Let's look at this one. Now this one I actually put a negative in front because what I want to show is that I'm opening it upside down. But it doesn't matter. As long as this is a 1 or a 1 right here, I'm going to first shift. I'm going to move, since it's plus 5, I'm going to move 5 to the left. Then I'm going to move 12 up. So I move 12 up, right? There's my vertex. Now, the negative means it's opened upside down. But still, look, if I move 1 to the left or 1 to the right from the vertex, I move down now, because it's opened down, 1 squared, which is 1. If I move over 1 to the right, I move down 1 squared, which is 1. If I move over 2, I move down 2 squared, which is 4. If I move over 2, I move down 2 squared, which is 4. Again, if I move over 3, I move down 3 squared, which is 9 units down. And again, if this is at 12, 12 minus 9 puts me at 3. So I'm hoping this is starting to make sense, that it's easy to graph parabolas because they follow this pattern. Now let's find out what happens if I do put a number in front of the x squared. In other words, let's put a 2 here and hit enter. Let's put a 2 here as well and hit enter. And let's put a 2 here as well and hit enter. And let's see what happens. Now let's think about this. When I move 1 to the right, I don't go up 1 squared. I go up 1 squared times 2. 1 squared is 1 times 2 is 2. If I move over to the left, which is negative 1, I don't move up negative 1 squared, but I do go negative 1 squared is 1, but then I times it by 2. So I move up twice as far. So when I move over 2, left or right, I normally would go up 4 because that's 2 squared, but I go up twice that distance. So instead of 4, I go up to 8. I go up to 8. And that's true regardless of where the vertex is. If on this bottom one, I went over here to the vertex 5, 2, and now if I move over 1, I would normally go up 1 squared, which is 1, but I go up twice that far, so I go up 2. If I go over 2, I usually go up 4, because 2 squared is 4, but now I go twice that far, which is 8. And remember, the vertex is at 2, so I go all the way up to 10. Same thing if I'm open down. If the vertex is at -5, +12, and I have a -2, that means if I go over 1, I would normally go down 1 squared, but now I'm going to go twice that far, which is 2. If I go over 2 squared, or over 2, that's normally 2 squared, which is 4, but now I go twice that far, which is 8. If I went over 3, I would normally go 9, but I'm going to go twice that far, which is 18 units down. And that principle applies even if it's a 3. I'm going to go 3 times as far as my normal amount that I would go. Ooh, 23 would be a huge amount. So if I plug in a 3, then if I move over 1, I'd normally go up 1 squared, which is 1, but now I go 3 times that far, which is 3. If I moved over 2, whether it's right or left, I normally go up 4. Now I'm going to go 3 times that amount, which is all the way up here to 12. So it's easy to graph these as long as you understand that concept that you're going to go up 1 squared, 2 squared, 3 squared, 4 squared times this scale factor outside, this multiple. Now, if you did it 1/2, the same principle applies. I'm just going to go half as far. So now, if I move over 1, oh, I haven't hit enter. There we go. If I move over 1, instead of going up 1 squared, which is 1, I go up 1 squared, but I go half of that, which is to a half. Now, if you can't graph a nice integer point, then what you would do is you'd go over 2, because when you go over 2, left or right, you normally go up 4, and what's half of 4? 2. That's a nice integer. So on this one open down, if I was to graph this, I would go over 5 to the left, because remember +5 means 5 to the left. I'd go up to 12. I would graph the vertex, because when you go to do this assignment, you need 2 points. You need the vertex, you graph the vertex, and then you graph one other point. So the next thing I'm going to do is say, well, if I went over 1 to the right or left, I would go to a half. Now, I might not be able to graph a half in the iExcel program, but if I go over 2, I can graph 2, because if I go over 2, that's normally 2 squared is 4, but I do half of that, which is 2 down from the vertex. Now, if I was to do 3, that's going to even be a little bit harder to graph, because again, in all these, if I moved over just 1 unit to the right or left from its vertex, I would move down a third. If I moved over 2, I would move down a third of 4, because remember, 2 squared is 4, and I'm going to do a third of that, which isn't a nice number. But what if I went over 3? What's 3 squared? 9. What's a third of 9? Well, it's 3. So I can do that. So if I'm doing a scale factor of 1/3, either opened up or down, I still graph the vertex, go to negative, or go to, so this bottom one here, I would go to -5. I would go up to 12. When I say bottom one, this one here that I'm graphing. And then instead of going over 1, because it won't let me go down a third on iExcel, instead of going over 2, it won't let me go down 1 1/3. I'm going to go over 3 and go down a third of 9, which is 3, and graph that point. And as soon as you graph the vertex and that other point, iExcel fills it all in. So transformational form is very easy. The next thing I want to talk about is standard form. If you graph it like this way, it's hard to find the vertex, okay? You can't, but what you do, and I hope I can bring, I think I exited out. But the vertex, remember the vertex, I'm going to write it here so you can see that freehand. The vertex, the x value for the vertex, is equal to, I'm not sure why that's doing, I want it to be pen, is equal to a minus b over 2a. And again, if you have to remember that from a previous lesson, you can do that. Oh, now let's go back here and let's look at this. If I wanted to find the vertex of this one, here my b value is 2, so I take 2 and I divide it by 2 times the a value, which is 1. So 2 over 2 times 1 is 2, 2 over 2 is 1, and I change the sign of it, it makes it -1. That tells me the vertex for this has an x value of -1, and look, there it is, it's right there. Vertex is -1. Now, so then the way you find the y value for the vertex is you just plug in -1. -1 squared is 1. Plug in -1 here, that's -2. 1 plus -2 is -1. -1 plus 1 is 0. So I found the vertex. Now, what's this? This is the number right in front of the x squared is a scale factor. Since it's a 1, I just move over 1 and I move up 1. I move over 1 and I move up 1. Or I move over 2 and I move up 2 squared, which is 4. Now, if I was doing this one, again, the scale factor is 2. But let's find out where it's going to go first. In other words, I'm going to take 4 as my b value. I'm going to divide it by 2 times the a. A is 2. 2 times 2 is 4. So 4 over 4 is 1. And I'm going to change its sign. So again, that vertex should still be at the -1 on the x-axis. But I haven't found the y value. I got to plug -1 back in. So I plug a -1 back in. -1 squared is 1 times 2 is 2. 4 times -1 is -4. So 2 plus -4 is -2 plus the 3 is 1. So my vertex should be starting right there. Let's see if it is. I clicked the wrong one. There we go. And lo and behold, there it is, right where I calculated it to be by finding the x value, plugging that x value in, finding the vertex. Now, the scale factor is 2. So that means if I go over 1, I'm going to go up twice as far as I normally would. So if I go 1 to the right or 1 to the left, normally I go up 1 because that's 1 squared, but now I'm going to go up twice that far. If I move over 2 to the right or 2 to the left, normally I would go up 4, but I'm going to go twice that far, all the way up 8 units. Now remember, my vertex was at 1, so 1 plus 8 puts me at 9. So now let's look at this one. Again, if I wanted to first find the vertex, I'm going to take -12, plug it right here for the b, divided by 2 times a. A is 3, so 2 times 3 is 6. What's 12 over 6? 12 over 6 is 2. Now remember, that was a negative b value, and then I'm going to change its sign, so it's going to be a positive 2. So my vertex will be on the +2, along the +2 at the x-axis. But I haven't found the vertical. Now I got to plug in that +2 into this equation. 2 squared is 4. 4 times 3 is 12. Put a 2 here. 2 times 12 is 24. 12 minus 24 is -12. -12 plus 15 is 3. So I found out my outcome when I plug in a 2 is up here at 3. So my vertex should be right there. Let's see if it is. Boom, there it is. Now again, my scale factor is 3. So when I move over 1, left or right, instead of going up 1 squared, which is 1, I would go up 3 times that far, which is up to 3, and I'd put a point there. If I moved over 2, I'd normally go up 4, but I'm going to go 3 times that amount, so I'm going to go up 12. 3 plus 12 is 15, and that's off the graph. I'm hoping this makes sense. If you do have questions, please do bring them to class, and I will explain it again, and hopefully this will allow you to do today's assignment.